Okay, all you people who are watching this, I'm going to go through not very much of section 2-3 notes. We're going to go through just this first page and talk about it. It won't take very long to go through, but then we'll save frequency polygon, pie charts, all that stuff, graphs that enlighten, graphs that deceive. We'll save that for tomorrow, so we'll just go through this first page. But your homework assignment is like doing some of these, like 1, 2, 3, 4, not 5. So just do 1, 2, 3, 4 for homework. But they do take a little bit of time because you are graphing some data and stuff. So I want to make sure I give you time to do that. But 1, 2, 3, 4 for homework. We'll go through these graphs and I'll show you kind of how this works. Okay? So first page. There are 4-ish different graphs. They talk just a little bit about a bar chart. You won't need to do a bar chart. You will do one of each of these for homework. So like number 1 is a dot plot. Number 2 is a stem plot. Number 3 is a time series. Number 4 is a Pareto chart. So you'll look at each one of these and that'll tell you what to do. Got it? Here we go. These are graphs that are enlightening. Enlightening means good. Enlightening means telling me more information. Enlightening means giving me more clues about the distribution of the data. Enlightening means telling me more stories about how the data is trending and that type of thing. Okay, enlightening is good. These are graphs. Okay, all right, the first one is a dot plot. Some stuff about a dot plot. Dot plots display the shape of the distribution. So you can see from down here that it's kind of normally distributed, like we have kind of a middle here and he's doing that kind of bell-shaped curve thing. So we can see that he is kind of normally distributed, where the average or the middle is like 68-ish, maybe something like that, right? Okay, you need to make sure that you are labeling graphs well. We did like section 2-1 where we did histograms. I think we did histograms for the first time. And we did not do a very good job labeling stuff. And I took off points for it. So circle this on example 1. This is the thing that you need to label at the bottom. Make sure whatever it is you're talking about, you have that one label. We'll circle all the labels that you need to make sure and have. Okay. So this one is pulse rates of males. Now, you do not need to have every place like labeled on here like they went by 10. So they did 40 and 50 and 60 and 70. Okay. This is a dot plot. So do you see this first dot right here? That means we had one person that had a pulse rate of 40. Now, how many like sections are in between each one? Like what are we going by?
2, I think.
We're going by 2s, right? Like in between 50 and 60, we have 50, 52, 54, 56, 58, 60, right? Okay? So we don't have the individual ones, right? So this dot right here is at 42. There was one person that had a pulse of 42. There were 1, 2, 3, 4, 5 people that have a pulse rate of 52. There were 2 people that had a pulse rate of 92, 94, 96, right? Do you see how this works? Dot plots. You're doing dots and going up. Sometimes they will do X's instead of dots, right? But you're going up. Got it? Yes, ma'am.
Since all of these are even, do you think that they cheated and multiplied?
They probably did the whole like only taking your pulse rate for 30 and multiplying by 2. Yes, that's exactly what they did. Okay, so we can gather that information from the graph. Exactly. Perfect. Awesome. Okay, so that is a dot plot. Okay, questions about a dot plot? Displays the shape of the distribution. That's this dot right here. It says that it is usually possible to recreate the original list of data values. Can I figure out what the exact data values are from here, right? I knew that this was exactly at 42. There was a bunch, like this was exactly at 90. This is at 1, 2, probably. I could recreate that exact list, okay? We talked about this when we did histograms, when you had like the frequency tables and I had classes. So like, let's say I had 61 to 70 and 71 to 80 and blah, 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 all the way down. And I had 5 students score in this range. Do I know what those exact scores are for a frequency table?
Nope.
No, I just know that there's 5 people that scored in between that range. So that integrity of the actual data values is lost, but in a dot plot, it is kept, right? We could recreate that actual list, okay? So that is a dot plot, okay? Stem and leaf plots, okay? They just call them stem plots, but this is a stem and leaf plot, got it? Okay, it shows the shape of the distribution, but it is sideways. Yeah, it's going like this. So this is kind of normally distributed. That's a really tall, like bell curve if it's on its side, but whatever. Anyway, so that's like that. It retains the original data values. So I could figure out that like this 5 and this 8, that's a 58. How many 58s were there? like, I don't know, 1, 2, 3, 4, 5, 6, 7, 8 58s, right? Do you see how this works? So I'm going to explain this a little bit more for Mary. She's probably never seen one of these before. Have you seen these before? In like elementary? No? You've never seen a stem and leaf plot? Okay. All right. So the way that this works is we have the numbers 40 and 42 and 50 and 50 and 52 and 52 and 52, blah, 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 right? Like this, okay? This is how this works. So here's some of your original data values, and then they keep going on forever, right? These are your tens units, right? So like 40 would start with the number 4, and 40 would be 40, so that is 40. This is 42, yeah? So it's like graphing, but it's like saving numbers, and it's showing your distribution and such, right? Okay, what is this number right here?
102.
That's 102, right? Okay, now people have done this before. Let's say I have 32, I have 57, 59, 61, 73, whatever, right? Okay, so I start with 3 and I do a 2. Make sure that even if you don't have a tens unit, you still put it down. So I will still put a 4, but I will not put anything after it over here. Does that make sense? This would be a 5, and then I would have a 7 and a 9, no commas in between, right? Then I would have a 6 and a 1 and a 7 and a 3, right? If this was 76, 76, 79, I would have a 6 and a 6 and a 9, right? After them. That's how my stem and leaf plot works. Again, make sure that you have, they don't have a title on theirs, but please put a title. Put your title right here. So we need to know what we're talking about. We're talking about male pulse rates. Okay, so make sure you put a title at the top of your stem and leaf plot. You guys have really never done stem and leaf plots before? What? Okay, they're nice. They're not too bad. Okay, the sample data are sorted and arranged in order, so that's a really nice thing. Also, are the sample data arranged in order here? Yeah, they are, right? This is 40, this is 42, this is 50, 50, 52, blah, blah, blah. They're arranged in order, yeah. 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 So anyway, okay, got it? Dot plots, stem plots. Okay, next one is a time series graph. Okay, time series graph looks a lot like a scatter plot, but I'm going to say scatter plot. Scatter, S-C-A-T-T-E-R-P-L-O-T. Do you know what a scatter plot is? We have your dots. Okay, but the scatter plot dots are connected with it, kind of like a trend line, right? Like a trend line would just be one line going through, right? But it's like all your dots are connected. And your x-axis, is that right? Equals some sort of time period, usually in years. It might be in months, right? So if they're talking about, like, they do this on the news. If they're talking about rainfall over the course of different months, like average rainfall per month, they might do a time series graph. This is another axis you have to label. So on this chart, you have 2 axes to label. You need to label what this is down here, and then you need to label what this is over here. Got it? So make sure you're putting like your labels on there, all right? And then your dots, they start and they go like this. So I can see that in the year 2010, we had about, I can't even read this because I underlined, about 160 law enforcement fatalities, right? Okay, what is this right here? Why is that so high? That was 9/11, right? So that was 2001. We just got done celebrating, not really celebrating. 9/11 was yesterday. The anniversary of 9/11 was yesterday, right? You guys were like not even conceived yet at that point, okay? And so there was a lot of law enforcement fatalities.
So was your father.
Sure.
Not even.
Sure. So there's that, right? That's why and so we can see that. That is information that we can find from the graph, right? Like we can see those trends, okay? Is there anything up here? Oh, reveals information about trends over time. We just discovered, hey, that was when 9/11 happened, okay? And we can see, according to this graph, in general, what is happening.
It's kind of like up, down, and then.
Law enforcement fatalities in general are doing this,
Yeah, slow.
right? They're going downhill, right?
Good.
Which is good, right? So in general, law enforcement fatalities are going down, okay? So we can see that over time. We can see those trends. But make sure you're labeling your axes, dots on your things and connected. Okay, the next one is very fun to say. It is a Pareto chart. Everybody say Pareto chart. Pareto chart. It's not a burrito chart. It's a Pareto chart. And here's what a Pareto chart is. A Pareto chart is a glorified bar graph.
A bar graph is basics, basically, right?
It's a glorified bar graph. It shows categorical data. Go up here to where it says categorical data and circle that. The data are all categories. They are not numbers on the bottom. Like over here, your x-axis was time. Those were numbers, right? Okay. Up here, you were dealing with pulse rates. Those are all numbers. Here, your overall categories are categories like jet skis and motorboat and utility fishing boats and inboard and sailboat. Okay. These are talking about boats that are stolen, right? Okay. Boats that are stolen every year. So thefts for jet skis is the most because people can like hop in them and just run off real fast, right? You know, and there's probably more jet skis out there than there are sailboats, right? Just out in general. I don't know. Be easier to transport. Okay, so these are thefts. Now, the way that we do a Pareto chart is it says it draws attention to the most important categories because
It's the highest and first.
highest frequency to least. So the tallest towers go first, and then they go down, 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 down. Okay? So if you were doing this as like eye color, hair color, favorite color, whatever, right? What's the most prevalent eye color? Is it brown or blue?
Yes, it's brown.
Brown. So brown would go first. It would be the tallest tower. Then blue, I'm sure, would be next, probably. Then maybe green, then maybe hazel. I don't know. Okay? But they would go in order of frequency. Now, what happens if I have two that are the same? I usually say go in alphabetical order. So if green and blue had the same number, blue would go first because B starts before blue B comes before G in the alphabet. Got it?
So it's the only difference between a bar graph and a Pareto.
Is the fact that it just goes in ascending order or descending order, I should say. Yep. A bar graph shows the relative distribution of categorical data so that it's easier to compare the different categories. Bar charts just don't go in order. Okay? I don't ask you to do any bar graphs because we don't want to do Pareto charts instead. Okay? Good? I'm not going to go any more than that because I want you guys to have time to do some of your graphs, but do 1 through 4, all right? You have one of each of these. Make sure that you are labeling. Oh, I didn't circle your labels. Label down here, label over here, right? Okay? It's behind this in your thing.
I'm adding to this.
Oh, there's 3 pages of notes for this section, right? So here's this, here's this. Do you see the one that has a cigarette on it?
My favorite.
Not that page, the next page. Okay, where it says statistics 2-3, pulse rates is the top. There you go. Got it?
It says,
Which one's the
1 through 4.
okay.
1 through 4. Questions? Any questions about that? Okay. Number 2, you use the same data as you did for number 1. Right? Okay.
Does it matter if we use dots or?
Or X's? I don't care.
No, I didn't.
You just do whatever you want to do. Okay? All right, there you go. Goodbye, people watching this video.